Hello, this is Mr. Pruitt, and today I'm talking about Newton's third law. This is the fourth part of a series on forces. This will also be the last video about forces that I put out. This one is about Newton's
Just
third
as
law,
review,
which has
remember
to
that
do
forces
with
are
pushes
forces.
and pulls. And we can look at these free body diagrams over here, and we can see opposite direction pushes and pulls. And these are balanced forces because what's happening is that the forces that are in opposite directions to each other are of equal magnitude. So these, remembering back to Newton's first law, remember that these particular objects would be either moving at constant speed or they would be at rest. Now we're less worried about in this lesson. We're less worried about the motion here, but we are looking at these opposite force pairs. So Newton's third law basically addresses the duality of forces, and what that means is that when two objects interact with each other, that they're going to both exert force on each other. So in the case of the picture over here, the car exerted force on the tree, and the tree pushed back with an equal amount of force, and so there was damage to the car and there was also damage to the tree. Now Newton's third law actually just says that for every action force, that would be the car running into the tree, there is an equal and opposite reaction force, which means that the tree pushed back in the opposite direction with an equal amount of force, and that's why they ended up changing the inertia of the car, and it stops. Now, Newton's third law applies in both collision situations, as objects coming together like this, or also in explosions, where maybe if you had two objects that were close together or touching each other, and then they were to push off with each other, they would both push off with an equal amount of force, regardless of the amount of mass that they have. To give you an example, let's say that you're wearing roller skates, and you are standing up against the wall, and you decide to push off against the wall and see how far your roller skates can take you. Well, when you push the wall, you push backwards against the wall, and the wall pushes forward on you. And since the wall is pushing forward on you, you can be pushed forward or out into the skating rink, so that you roll forward. And so the amount of force that the wall pushed back on you whenever you pushed on it is equal to the amount of push that you gave to that wall. So what's the motion? What motion is described by Newton's third law? Well, basically, it's what we were just talking about. That when these two objects interact with each other, they apply force on each other, and those forces are in opposite directions. So, if we look at the lady in the lab stool, her body is applying a downward force on the stool. The stool is applying an upward force on her, and they're of equal magnitude. So she stays in basically the same position, because the action force, the downward action force, and the upward reaction force are equal to each other in opposite directions, which allows her to just sit there. Alright, I hope this was helpful for you, and this is the last one on forces. Have a great day, and I will see you when we talk next time when we talk about works. Thank you. Bye.